perpendicular lines and perpendicular bisector constructions. Today we're going to kind of switch it up and go into constructing shapes. So we're going to talk about hexagons and equilateral triangles today. So here's going to be the construction that's going to help us with the hexagon and the equilateral triangle actually. So going to the notes, a few things we need to know for vocab. So definitely if you need to pause this and write it down, do it. But congruent means two objects or shapes that have the same measure. So for example, angle A is congruent to angle B. Now, the symbol for congruent is basically an equal sign with a little squiggly over the top. And angles can be congruent, segments can be congruent, triangles or quadrilaterals could be congruent, any shape could be congruent, angle or side, and it just means they're the same size. Now, why isn't it just equal? Like, why wouldn't it just be called equal? And the reason it's not equal is because P to Q is this line here between P and Q. XY is this line or segment between X and Y. They're not the exact same one, right? This one's here, it's blue. This one's down here, it's orange. But they're the same size. Like, they're basically the same. Congruent just means same size. You can almost think of it as equal. It's just a different shape, but the exact same one. So for example, if we have two triangles here, ABC and CDEFG, they're congruent. They're the exact same triangle, exact same size, but this one has a point A, this one has a point E. So it's just like a different shape, but it's the exact same one. So that's the only thing about congruent. You could basically think about it as equal. That's why there's a little squiggly. It's like basically equal. And then why that's an important vocab word is because we're going to talk about regular polygons. So a regular polygon is a shape with all sides congruent. So let's say this side was 6 inches long, and this side would be 6 inches long. This side would be 6 inches. All the sides are 6 inches long, right? So all the sides are the same, and all the angles are the same. So all the sides are congruent, all the angles are congruent. That is called a regular polygon, just like the typical one you think of when you think of that shape. So when you think of this is a hexagon because it's 6 sides, like this is what you think of. You don't really think of, like technically that's a hexagon. If I drew it with 6 sides, let me just draw a different one. I'll do black here in the middle. Like 1, 2, 3, 4, 5, 6. Technically, this is a hexagon. It's got 6 sides, but it's not really what you think of. So we think of regular ones. Usually, it's all the sides are equal or congruent, and all the angles are congruent. So for example, is a square a hexagon? Or is the square a regular polygon? Yeah, all the sides are equal in a square. This little tick mark just shows all those sides are equal. And then all the angles are 90, so we know all those angles are equal. So a square has all equal sides, all equal angles. It is a regular polygon. Last vocab word, there's a lot of vocab in this lesson, is an inscribed polygon. And all that really means is an inscribed polygon is a polygon that's in a circle. All the points of the polygon hit the circle. All the vertices, we call them vertices, where two segments come together. So all these are in a circle. It's called an inscribed polygon. So today we're going to learn how to construct an inscribed hexagon, this shape with 6 sides, and an inscribed triangle. So let's look at that really quick. So to construct a regular hexagon, honestly one of my favorite constructions, we just need a circle from A to B. Doesn't matter where you start. Ooh, let me get my circle. Boom. Now I could go from B to A as well. We're going to make another circle from B to A. That's going to have 2 intersection points. If we make circles from there, we get more intersection points here. Here's another intersection. Here's another intersection. We can keep going around and we'll make this like flower looking shape. But if you look, there's 6 points on the hexagon or on the circle, and it makes a 6-sided shape. It is a hexagon. You just go all the way around, and then that polygon tool in Desmos will help you connect them to make that shape. So that's how we construct a hexagon. So there's some practice problems that we did in class. We just did one here. The big thing you got to do, just make sure you start with a circle. Then you use those intersections to keep going around until you get 6 points. Fun construction. Looks really cool. I don't know. I just like it. Oh, I missed that point. Be more accurate than me. So how do we know all the circles in the diagram are congruent? Well, A to G was the radius. So if I make a circle G to A that has the same radius, then this is the same intersection. So that's going to be the same radius. That's the same radius for both circles. So we just keep going around. Always the same radius. Now we're going to construct equilateral triangles. So we can use the construction we just learned. Let's just make it. And now we're going to think about how could we make this an equilateral triangle in the circle that I missed. Gotta hit the intersection. So there's 6 points. Now I only want 3 of them, but I want to just choose every other one and we'll get an equilateral triangle in that circle. So that's an inscribed equilateral triangle. I could also choose these points. We just want to go every other. All those triangles have equal sides. If I did like, that's not every other, that's not an equilateral triangle. This side's smaller than this side. That one didn't work. So you want to just go every other, right? 6 is a hexagon, 3 is a triangle. You just go every other. It's pretty easy once you know the hexagon construction. Bam, there it is. So basically fun stuff there. And then for that cooldown, you want to construct an equilateral triangle inside this circle.